Good morning everybody, myself Acharya Vishvendra, and today I'll discuss a worksheet on charged particle in magnetic field. So let's start with the first question, the expression of the magnetic force. So it was experimentally observed that when a charged particle is placed near a current carrying wire, it deflects in a direction which is perpendicular to the velocity. So there appeared some kind of mysterious force which deflected the particles in a direction perpendicular to its velocity. So from there, after calculations, it came out that there exists certain things called as the magnetic field, which applies a force perpendicular to the velocity. And after making the empirical formula and finding the exact relation, it came out that it can be expressed as QV cross B by experimental verifications done by various scientists, especially Lorentz. He calculated, he gave this empirical formula. So the expression is Q into V cross B. The important concept here is that magnetic force is perpendicular to the velocity. That means it cannot increase the speed or the magnitude of velocity, or work done by the magnetic field on a moving charge is zero, or there is no change in kinetic energy or the magnitude of momentum of a charged particle which moves in a magnetic field. So these concepts can be fetched out from over here. Next, second question is conditions for which magnetic force is zero. So magnetic force is QV cross B. So it will be zero when either Q is zero or V cross B is zero. Now V cross B can be written as VB sin theta. So VB sin theta is 0. VB sin theta will be 0 when either V is 0 or B is 0 or sin theta is 0. And sin theta is 0 when theta is 0 or theta is 180, or any combination of all of these. So this concept we can analyze that force on a charged particle is 0 when either it is neutral, or it is at rest, or the field is 0, or the angle between field and velocity is either 0 or 180. That is, velocity is either parallel to the magnetic field, or it is either anti-parallel to the magnetic field, or any combination of all of these. So these are the various conditions for zero magnetic force. Next question, we have magnetic force and velocity are inclined at, as I discussed earlier, these are perpendicular to each other, so angle will be 90. Next is dot product of force and velocity, that will be 0. Next is work done by magnetic field on a charged particle. As I explained earlier, force is always perpendicular to velocity, so there is no component along the velocity, so work done is F dot ds. Now displacement will be parallel to velocity instantly for instantaneous case, and velocity is perpendicular to force. That means work done by magnetic field on a charged particle will be 0. Next is power given by the force. So power is also F dot V. Since F and V are perpendicular, so the power will also be 0. Next, does the speed of charged particle change in magnetic field? No, as I explained earlier. Next, does velocity of a charged particle change in magnetic field? Here is the important question. Velocity may change, because if angle is 0 or 180, then in that case force will be 0. So force is 0, that means acceleration will be 0, that means velocity will be constant. So in two special cases, when velocity is either parallel or anti-parallel to magnetic field, there will be no change in velocity. In all other cases, velocity will change. So in general, we can say that velocity will change, but two special cases arises where velocity may not change, hence the word may is used here. Next is a question, there is a charge 20 millicoulomb, velocity is 2i minus 3j plus 4k, and magnetic field is 3i plus 2j minus k. We need to find, the first is speed, so speed is instantly magnitude of velocity, so instantaneous speed is magnitude of instantaneous velocity. So that will be 2 square plus 3 square plus 4 square, that will be root 29. Then we need to find magnitude of magnetic field. It can be done by squaring 3 square, 2 square, 1 square, that will be root 14. Now another question is on calculation of the magnetic force, so that will be QV cross B. Q here is 20 millicoulomb. V cross B can be found by the determinant IJK. V is 2 minus 3 4, and B here is 3 2 minus 1. And after solving this determinant, we get magnetic force as 20 millicoulomb, I cap into minus 5 minus j cap into minus 14 plus k cap into 13. This is solution of this determinant. Now another question 12th is the magnitude of force. So magnitude of force is 20 into 10 is to the power minus 3 into square of